Hello everyone, I'm Mamatha, Assistant Professor in the Department of Electronics and Communication Engineering, JNTU College of Engineering, Anantapur. Today's subject is linear IC applications. First of all, we should know what is linear, what are linear IC, and what are linear IC applications. So linear is nothing but linear is any circuit which consists of components, linear or non-linear components, and then the variation of output with respect to input, or else the voltage and current relationship of that circuit is linear. We call it as a linear circuit. And if the relation between voltage and current is a non-linear, then we may say that the non-linear circuits. Examples of linear circuits are nothing but resistor, capacitor, inductors are placed alone in the circuit for any application, and the characteristics of that circuit voltage and the current variation should be linear. Then we call it as a linear circuit, and the components present in that also we call it as linear components. And the nonlinear components are nothing but diode, transistor, FET, all those are the nonlinear devices, and the devices present in that circuit also gives the nonlinear characteristics. Nonlinear characteristics are nothing but input and voltage variation in that circuit is a nonlinear. So we subject here is a linear and IC applications, linear IC applications. That is, we are using ICs, those ICs or the linear ICs and the applications of those linear IC applications. So first of all, we should know why ICs are important in present scenario, and then what advantages are there, what disadvantages are there. Before going that, we should know we are using so many electronic gadgets in our present life. So without phone, we can't, right? So without laptop, we can't. So why, how those electronic the gadgets size is minimized every day with the technology increasing. So in olden days, we also know that the computer size is a room size, right? And with the increasing technology, size of the computer is reducing, and now we are able to carry in our hands of a computer. So how the technology happens is with the help of a ICs, right? So that's what here we should know what exactly the IC, and then what advantages and disadvantages of integrated circuit. Integrated circuit. So here itself we are having that integrated. All the circuits are integrated on a single semiconductor material. That semiconductor material again based on that application, maybe a germanium, silicon, gallium arsenide, right? But generally we prefer to use the silicon because of its advantages. Now we'll see that what contents are there in the unit 1. We should know what is IC and what classifications of IC, and then how that IC chip size and the complexity is varying, and then the information of a basic IC. What is a linear IC we are talking, that is a 741. 741 is the best example of a linear IC. So here we should know the basic information of op-amp 741 and what are the features of that, and then ideal operational amplifier and then practical operational amplifier. So there should be a lot of difference between ideal and practical, and then what internal circuit is there for operational amplifier, and then characteristics in terms of DC and AC. So exactly, if you see that what is IC, AC is not IC is nothing but the integrated circuit. That's the abbreviation, and it is also called as a microelectronic circuit and also called as a microchip or simply chip. It's an assembly of electronic components fabricated on a single unit. So, in which miniaturized devices, both active and passive components will be there. Active devices we know like transistor, diode, FET, right? And then passive components are resistors, capacitors, inductors, right? But generally, inductors uh, cannot be used in the IC. Only resistors and the capacitors will be used. So, and then those interconnections of both active and passive components can be built upon a thin substrate of a semiconductor material that is typically a silicon. If you see here, that is the diagram. and this is the IC. IC looks like this, and then this is the way called as a pin configuration of IC, right? And then how that the connecting wires. If you see here, these are the connecting wires, and this is the silicon chip, and this we call as a package. And though these all call as the terminal pins. Right, so here these we call as the individual components, electronic components, or the discrete components. If we can connect the application, any application with the discrete components, but it takes more space, more power, right? And then very much like care should be taken for getting input and output. If there is any small connectivity in the circuit on the breadboard, will not get that output. So that all can be removed with the fabrication of all components on a silicon wafer. So this IC looks like, and then we are going for 741 IC, right? So that we'll see that how many pin configuration, how many pins are there for that, and what is a package, and then what applications are there with that IC, that we'll see. And what exactly the advantages and disadvantages of integrated circuits? Advantages, we'll see that basic advantages are nothing but the size. So size of the IC is extremely small than that of the discrete components. If we connect all the discrete components like resistors, capacitors, and then the divisors are non-linear or else the active divisors, if we use and if we connect all together, it takes more space. So all the components can be placed in a single silicon wafer that obviously takes less space, and also weight. So weight of an IC is very less as compared to discrete circuit, and it is also more reliable. So we can the input and outputs are the whatever the components we take, and then whatever expected inputs and outputs are there for any circuit, that accurate result we can expect that. And then because of their smaller size, it has a lower power consumption. If size is low, means power consumption is also low. It can easily replace, but it can hardly repair. So we cannot repair any IC. If there is any damage in that IC, that VC itself is a IC itself is a failure one. So because of an absence of parasitic and capacitances affected, it is increased operating speed. So speed of that ICs are also higher than that of the discrete component circuit. So because of the parasitic and coupling capacitances. So what exactly the parasitic capacitances and then coupling capacitances we'll see later. But the effect speed of that IC is high, and then temperature difference between components of a circuit or the small, and then it has a suitable for small signal operations, and the reduction in power consumption is achieved due to extremely small size of an IC. And then ICs, any circuit is in the real world have both advantages and disadvantages. So what exactly the disadvantages of an IC is nothing but coils or inductors cannot be fabricated. There will be some applications where inductors are must to use, but in IC fabrication, inductors cannot be used. It has to handle only limited amount of power, and then high grade PNP assembly is not possible, and also it is difficult to achieve low temperature coefficient. So the power dissipation is limited to 10 watts. Low noise and high voltage operations are not easily obtained. So now what classification of ICs are there? So integrated circuits are classified based on the size, based on the technique, based on the application. So based on the chip size, again small scale integration, medium scale integration, large scale integration, very large scale integration. So size of that one is nothing but very small scale integration is nothing but the number of components present in that IC will be very low. Medium is nothing but somewhat higher than the small, and then large is nothing but somewhat higher than medium, and large, very large is nothing but higher than the large scale. And based on the fabrication, so monolithic integrated circuit, and then thin and thick film integrated circuits, hybrid or multi-chip integrated circuits are the classification based on the fabrication technique. And based on the application, linear integrated circuit and then digital integrated circuits. So, but our subject is a linear integrated circuit. So, we'll concentrate much on linear integrated circuit. So, linear integrated circuits deals with the voltage and currents which are continuous with the time, whereas digital integrated circuits deals with the digital inputs like ones and zeros. And then how many in like devices will be placed in the classification of IC based on the chip size. So small scale integration less than 100, medium scale integration 100 to 10,000, large scale integration 1000 to 1 lakh, very large scale integration over 1 lakh, ultra large scale integration is also there, that is over 1 million devices are fabricated in that one. Based on that fabrication, three types based on the fabrication are the monolithic, thick thin film, and then hybrid IC. So monolithic is nothing but the type of all active and passive components are formed simultaneously by diffusion process on a single silicon chip. So it is followed by metallization process to interconnect the components to obtain the required circuit. So they are generally used in low power applications, right? So and again, second one is a thick and thin film IC. These slightly larger than monolithic ICs, and the passive components like resistors and capacitors are integrated, whereas diodes and transistors are connected as a discrete components to obtain the required circuits. So that's a thick and thin film ICs incorporate both integrated and discrete components, right? So all the passive components will be connected as a IC, and then active devices have to be connected outside the IC with the discrete components. So this thick and thin film IC fabrication is nothing but the combination of both integrated and discrete components. Hybrid IC is nothing but hybrid ICs are the combination of two or more monolithic ICs, or it is produced using monolithic IC and thick thin film integration circuits. So these are used in high power applications. And then these linear ICs are employed where the relation between the circuit's input and the output is linear. The operational amplifier, often known as a op-amp, is a significant application of a linear IC. It's a digital circuit is one of the either or on and off in a between digital ICs employed in such circuits. They have a wide range of use in computers and then logic circuits. This is the classification of ICs under the technology. It may be a linear IC or maybe a digital ICs. Now, the based on mode of operation. Again, operation of ICs are also differ. So based on mode of operation, these are the analog IC or linear IC, digital IC or non-linear IC. So analog ICs are nothing but integrated circuit or the discrete networks which processes the signals that are continuously variable like an audio signal. The values of voltage and current may vary continuously between minimum and maximum values. They are available commercially as a voltage comparators, regulators, op-amps, etc. Whereas digital ICs or nonlinear ICs are nothing but the digital ICs are the logical networks capable of performing mathematical calculations and are commercially available as memory chips, microprocessors, microcontrollers, counters, logic gates, resistors. The input output values either logical high or low. And then based on that IC chip size and the circuit complexity, up to until 1950s, the electronic device technology was dominated by the vacuum tubes. So initial electronic devices are the vacuum tubes that we all know. In the present day, electronics is the result of invention of the transistors in 1947. Right, so the invention of a transistor by William Shockley, Walter H. Brittain, and John Burdeen of the Bell Telephone Laboratories was followed by development of a integrated circuit. The concept of ICs was introduced at the beginning of 1960 by both the Texas Instruments and Fairchild Semiconductors. Since that time, the size and the complexity of ICs have increased rapidly, as shown by the brief chronology. Over the years, the device density has increased together with the increase in the chip size. The chip areas range from 1 mm to 1600 miles to for the SSI chip 1 centimeter for large scale chip. So invention of a transistor happened at 1947, development of silicon 55 to 59, silicon planar technology in the year 59. First ICs, a small scale integration, only 3 to 30 gates per chip in the year 1960. Medium scale integration, that is 30 to 300 gates per chip in the 65 to 70. Large scale integration, 300 to 3000 gates per chip in the year 70 to 75. Very large scale integration, more than 3K gates per chip in the year 1975. So now all that is about introduction of IC and the classification. Now we enter into exactly that linear IC. The best example of linear IC is the operational amplifier. So what is operational amplifier? Where we can use this operational amplifier, and then what advantages, disadvantages, what are the characteristics, finally the applications. So operational amplifier, generally we call it as an op-amp. An operational amplifier is an integrated circuit that can amplify weak electrical signals. So it has two input pins and one output pin. Op-amps or linear divisors that are ideal for DC amplification and are used often in signal conditioning, filtering, or other mathematical operations. Mathematical operations, so we can do addition, subtraction, integration, and the differentiation. So why this operational amplifier named as operational amplifier? This circuit is named as operational amplifier means initially that circuit, the designed circuit is used to perform operations, mathematical operations. So those mathematical operations are addition, subtraction, integration, and then differentiation. Later, that circuit with the modifications that used in both the AC amplification, the DC amplification, and the mini applications. So an op-amp can be a non-inverting amplifier, a phase shifter, scale changer, adder, or summing amplifier, differential amplifier, differentiator, integrator, voltage to current converter, right? So there are many applications of operational amplifier. If you see here, this is the symbol of a operational amplifier. The symbol shows that here this we say that this arrow says that the current direction, current flow direction, right? So this circuit has two inputs, we called as a non-inverting input with the plus sign, inverting input with the minus sign, and it needs two power supplies. Again, one is a positive power supply, second one is a negative power supply, and then one output will be there to collect the performance or else the response of that circuit based on the inputs. So, operational amplifier is called as an op-amp that we said, and it is an integrated circuit primarily designed to performing analog computations. It has a very high voltage gain, typically of the order of 105, and that is 100 dB. So this is the IC741 symbol, right? And this is the internal diagram of that IC. So inside this IC there is the package, plastic package, this we called as that, and inside that IC this is the circuit. This is the operational amplifier with the two inputs, two power supplies, and then one output. So here we also know that the way the input terminals are connected to this pin. So here, starting from the notch, this is the notch. Starting from the notch, we should find out this is a 1, 2, 3, 4, and then 5, 5, 6, 7, 8. So for which pin input is connected? Now inverting terminal. So inverting terminal is connected to the pin 2, this one, and then non-inverting terminal is connected to 3, this one, and then 4 is nothing but the power supply, so this is power supply, and then 5 is the no connection, and the 6 is the output, right? So here this side 6 is the output, and then 7 is again power supply, and then 8 and 1 are the no connections. NC. We say that NC. Why NC is what there in any ICs or nothing but for future purpose. So if there is any advancement happened in that one, that will be utilized with the no connection pins. So here we need to find out that the notch. Wherever notch is there, we need to start numbering from that notch. So here is a notch, then this is one, not this one, right? So here in this way, 1 2 3 4 and then 5 6 7 8. So IC 741 is a 8 pin IC. And then for what pins this input and output power supply terminals are connected also we should be aware. So for 2 and 3 input, 6 is the output, and then 4 and 7 are the power supplies. And then in detail like the way the second pin is connected, where third pin is connected, and then power supply is 7 and 4, which one is a positive power supply, which one is a negative power supply also we should know. And then what are the features of 741 IC? The features of IC 741 op amp are the no frequency compensation is required, short circuit protection, offset voltage null capability, large common mode, and differential voltage ranges, no latches. So here, this one pin out offset null we call the top 5.